Hello, this is Ryosuke Tsumura from Waseda University in Japan. We would like to show the preoperative needle insertion path planning for minimizing deflections in multilayered tissues. Fine needle deflection is a problem encountered during needle insertion into soft tissue. Although an axial rotation is an effective approach for minimizing deflection, needle deflection still depends on the insertion angle with respect to the tissue boundary. Since the human body consists of multilayered tissues of various shapes and mechanical properties, the preoperative planning of optimal paths is a key factor for achieving a successful insertion. In this paper, we propose an optimization-based preoperative path planning model that minimizes needle deflection during multilayered tissue insertion. This model can determine the optimal path based on the sum of insertion angles with respect to each tissue boundary that the needle passes through. To increase the accuracy of the model, we incorporated two types of weighting factors into the model. As one of the factors for causing a large deflection, the effect of the tissue boundary distance needs to be accounted for in the weighting factor. According to the previous research, the deflection was increased almost linearly depending on the insertion depth. Then, once the deflection occurs at the tissue boundary, we assume that the final deflection differs depending on the distance between the tissue boundary and the target. The deflection also differs as a result of mechanical properties of the tissues, but it doesn't seem realistic to estimate the deflection considering uncertain factors such as viscous elasticity. Therefore, instead of estimating the deflection value, we consider the probability the deflection occurs as a result of insertion angle and mechanical properties of the tissue. By considering the probability, the effect of those uncertain factors, which are difficult to be included as parameters, can be effectively captured in the path planning. To validate the model, we performed experiments involving two scenarios of 2- and 3-layered tissue. The result shows that the proposed model is capable of determining the optimal insertion path in those scenarios. In order to apply the proposed method to clinical cases, it will be necessary to measure the tissue boundary automatically from preoperative medical images, such as a CT or MRI, for calculating the insertion angle and the tissue boundary distance. Thank you for your kind attention.